Hello and welcome. Now that we have a good basic understanding of artificial intelligence, I suggest we explore together how it can be used, how can we leverage it. First, let's take a quick look at the tools that we use. There are indeed a lot of languages and programming platforms, but let's see only the most popular ones, the ones that will inevitably cross your path. The oldest are the professional and paid platforms that were created in the 1970s. We mainly think of SAS and SPSS that has been bought by IBM in 2009. Not to forget Microsoft Excel, that should not be underestimated. The 90s saw the beginning of open source programming languages. Little used at first, these languages became more popular in the early 2000s with the advent of big data and because of their simplicity and versatility. The main focus was on R and Python, distributed on the platform called Anaconda, and later Julia, launched by MIT in 2009. These languages provide access to algorithm libraries, whose most currently known are scikit-learn for machine learning and TensorFlow for neural networks. Their use has been very simplified since 2015 with the use of notebooks, which are very useful programming tools. Friendly and easy to use, they are made up of cells that can accommodate text, code, graph, or illustrations. They are mainly used for exploration, simulation, communication, or teaching. The most well-known is the Jupyter Notebook, a contraction of Julia, Python, and R. Finally, very recently, in the early 2010s, the major players launched the concept of cloud-based platforms. Amazon led the way with AWS, quickly followed by IBM Cloud and Google Cloud Platform. Those platforms are worth to follow closely because they will democratize and revolutionize the approach of AI. One of the latest studies that McKinsey publishes regularly shows us the areas where, according to them, artificial intelligence has the greatest potential in terms of added value. Travel, transportation, and retail come out on top. We also find industries for which the application of AI is less obvious, but which nevertheless offers interesting solutions such as agriculture. The banking sector is further down the list mainly because of its resistance to change and strong legal pressures. The security and defense industry came last, but most certainly because it doesn't share all of its research. Here we see a non-exhaustive illustration of the common application areas of artificial intelligence. It contains the 5 pillars of the smart city: traffic, energy, health, education, and security. Referring to security, for example, we can mention the example of China, which is making considerable progress in this area. In a city of more than 10 million people, the average time for the police to apprehend a criminal is 7 minutes. Facial recognition is enhanced by silhouette recognition and walking pattern recognition. The most remarkable advances are probably in the field of health, with the automation of medical diagnosis, especially through imaging analysis. Let's not forget, of course, the already common applications in the fields of distribution, for example, supply chain, optimization of prediction of purchasing behavior, in finance, with, for example, credit risk management or market forecasting, in telecommunications, with, for example, churn models, and manufacturing with quality or safety management. The global market estimate for artificial intelligence revenues in 2019 was more than 90 billion by 2025. This estimate is most likely already obsolete. A recurring and important question has been for the recruitment of data scientists and the creation within the company of a team dedicated to data science. It is first important to understand that a data scientist is a convergence of three areas of expertise. Mathematics first, as the foundation of modeling and AI. Secondly, computer science, which is the necessary tool for computation and deployment of algorithms. And finally, business management, because the data scientist in charge, among other things, of developing cost functions within an algorithm must have a precise knowledge of the field in which she is acting. Only recently, we saw university programs attempting a conjunction of these three areas. Until now, a data scientist had no choice but to do a master's degree in mathematics, a master's degree in computer science, and an MBA. The data scientist, however, does not act alone, and other skills are necessary within the team. If a data scientist specializing in deep learning is not essential, it is, however, necessary to support data scientists with data analysts who will stop before modeling, data architects who will ensure the quality and availability of data, and developers in charge of the application environment. Don't forget the project manager, essential in a team with a variety of expertise. And finally, a system architect who will be essential to the management of the IT environment and especially cybersecurity. Starting a project in data science, modeling, or artificial intelligence can be intimidating and even a bit scary. The added value of these projects, however, is real, and you should not delay because the industry is moving fast and it is never too late. As with any other project, it is essential to have a strategy, that is, to precisely define the objectives. Now, let's not kid ourselves. The introduction of automation and decisions will shake up habits and often generate strong opposition, pushback, resistance, friction. It is therefore advised to have a change management plan. You can get inspired by Kotter and start with a sense of urgency, the creation of a team, and the identification of champions supported by a strong communication. The environment is paramount, and we'll start first with the digital transformation of the company. To tackle such a project on your own is strongly not recommended. It is wise to find partners and look for professional support. A final word on responsibilities. Any decision implies moral, civil, and legal responsibility. It's difficult, however, to make the machine responsible. There is a legal void at this level that the industry is working to fill. In the meantime, our advice is first of all to fully understand and measure the impact of the project. Then to be transparent, including in the technical explanation of the modeling methods used. Communicate, communicate, and communicate again. Explain and educate all stakeholders. Your enemy is ignorance, because everything we don't understand scares us. Protect your data, as this is part of your legal responsibilities. And as with any other project, control and control again. If the will of humans is to transfer to the machine the burden of decision making, let's not kid ourselves. No one, will be able to hide behind the machine to avoid responsibilities. What we need to remember is that you have to start early. Don't wait. It's about your immediate competitive advantage. An AI project must start at the strategic level with the identification of the problem to be solved, the decision to be made, the optimization to be achieved. The need for predictive tools and models and the sources of necessary data will follow logically. Precisely identify the skills you will need and build your team. And don't try to do it alone. Get help. Manage change and communicate a lot. Well, it's almost over. We have a last question. Does morality have a say in AI? We will try to answer in our next and last course, where we will address fears and ethics. See you soon.